What's going on, guys? The question is asking, use the cofactor method to find the third column for the inverse matrix of 2 1 minus 1 3 1 1 4 1 2. If A is a 5 by 5 matrix with determinant of 2, then find the determinant cofactor A. So use the first question is find the inverse matrix using cofactor. So whenever they ask this kind of question, the first formula we have to remember is uh, a a inverse is equal to 1 over determinant A times cofactor A transpose. So this is how we find the inverse of the matrix. So let's see how we can find it. And the second question is then, so let's not worry about the second one for now. So let's find the inverse using this one. So if I to find the inverse, first I have to know the determinant of A. So determinant of A is going to be, okay. So determinant of A is going to be equal to uh, plus minus plus method. So if I take 2 here, it's going to be AD minus BC, so it's going to be 2 minus 1. Then I'm going to get minus 1 right here. If I take minus 1, I will get 3 times 2 is going to be 6 minus 4. 6 minus 4 is 2. Then minus 1 right here. If I take minus 1, I will get 3 times 1, 3 minus 4 is going to be minus 1. So since we have this one here, 2 times 1 is going to be 2 minus 2 plus 1. So 2 cancels each other, so the answer is 1. So this is my determinant A. Now I have to find the third column for the inverse matrix. Third column for the inverse matrix. So to do this one, we have this A right here. So inverse matrix means we have to first. So in this one, the third row is going to be third column because this is A transpose. This is where we have to be careful. When we find cofactor, we have to find the cofactor of A transpose. So let's list A right here. A is going to be 2, 1, minus 1, 3, 1, 1, 4, 1, 2. So if you find the A transpose, it's going to be flipped around, right? So it's going to be 2, 2, 1, minus 1, 3, 1, 1, 4, 1, 2. And they are asking third column. So third column is going to be this one, 4, 1, 2. Now I have to find cofactor of this one. Cofactor, this location is 1, 3. So it's going to be cofactor of 1, 3, right? Cofactor of 1, 3 is going to be minus 1 to the power of 1 plus 3 times determinant of this one. So determinant of 4 is going to be 1 times 1. Let's list them first. So 1, 1 minus 1, 1, which is going to be equal to 1 times 1 is 1 minus 1 times 1 is going to be minus 1. So 1 minus minus 1 is going to be plus 2. Since the power is going to be even number, it's going to be a positive 1. So it's going to be just 2. Then cofactor 2, 3 minus 1 to the power of 2 plus 3, determinant of uh, 1, 1, 1, 1, then minus 1 times 1 is going to be 1 minus minus 1. No, wait a minute. So this is not correct. So if I take 1, I will eliminate all the horizontal and vertical components of it. it's going to be 2 3, 2 3 minus 1 1. So if I find the determinant, it's going to be 2 times 1 is going to be 2, minus 3 is going to be plus 3, so it's going to be 5, and since the power is an odd number, it's going to be negative 1. Since we got 2 to plus 5 is going to be minus 5. And then we have cofactor 3 3. So minus 1 times 3 plus 3, determinant of so 3 3 is 2. So if I take the determinant of this one, vertical and horizontal cancel, so this one is 2 3 1 1. So if I find the determinant, 2 minus 3 is going to be minus 1. Since the power is even number, is going to be positive, so it's not going to change the sign. So these are my three cofactors. So now I can apply directly in the A inverse to find the third column. So 1 over 1, determinant is 1, so it's going to be 1 over 1 cofactor A transpose. We have this list 2 minus 5 minus 1. It's going to be the same answer, so we can say A inverse is going to be 2 minus 5 minus 1. Then at the end you can state, therefore the column for the inverse matrix of the third column for the inverse matrix is these three numbers, and that's going to be the final answer. And the next question is asking, if A is 5 by 5 matrix with a determinant of A, then find a determinant of cofactor A. So let's see how we can do this. So before I do that, let's erase this whole part. Okay. So before I do that, I erase this thing. Okay, let's do this. Now we have that question right here. Let's see how we can do. So the first of all, whenever they ask cofactor and determinant, the main rule is the main formula we have to remember is this is going to be the main rule. A inverse is going to be equal to 1 over determinant A time cofactor A transpose. So then we will see what we can do. So since they have a given determinant of A, determinant of cofactor A, the best things to do is we first of all let's find determinant in both sides. So determinant in both sides. So determinant A inverse is going to be equal to A inverse is going to be equal to determinant of the whole thing, right? So it's going to be 1 over determinant A times cofactor A transpose or determinant. Now what I have to do, 1 over determinant A inverse can be written as 1 over determinant A equal to determinant of 1 over determinant A. So I can, okay, let's separate this one. Determinant of 1 over determinant of A, then determinant of cofactor A transpose. So these are two different things. Then what we can do, we can say this is 1 over determinant of A equal, no, I can plug this value right here. So determinant of this one is going to be 1 over, and determinant is given here, it's 2, and the main determinant is going to be the, if it's 5 by 5 we have to power by 5, so if I do that, the determinant is already taken. That's the main thing, like we have to power by the matrix number. If it's 4 by 4 we have to power 4, and that's going to be the determinant, and determinant A is a number, so we can just power it. Then determinant is cofactor A transpose. So according to determinant rule, any transpose of the cofactor or whatever it is going to be itself. So it's going to be determinant of cofactor A transpose is equal to cofactor determinant of cofactor A. That's the determinant rule. Any transpose can be written as itself. And here I can plug the 1 over 2. So 1 over 2 to the power of 532. The question is find determinant of cofactor A. Okay, so this is the question. Now determinant of cofactor A. So determinant of cofactor A is going to be equal to 32 over 2, which is equal to 16. So this is the final answer. Determinant of cofactor A. So that's it. And I hope you guys like this video. See you next time.